Then you got to follow the directions, okay? So let's go through that process because you have to be able to do it. And that means you may have to practice on your own. All right, here we go. There it is. Now, in order to complete the square, this number has to be gone and that number has to be gone. So I'm going to move the 6 over. And I'm going to multiply everything by 2. Now I've taken care of my issues. My issues are this, I have to be able to complete the square. That's got to be gone. That's got to be gone. So I moved it over times by 2. Now I'm ready to actually complete the square. So lucky this time, no fractions. Half of 8 is 4, squared is 16. So I'm going to add 16 to both sides. Make sure you add it to both sides. Some of you didn't, that's bad. This is a perfect square. X minus 4. And this side is 2y plus 4 if I add these things together. Now I just put it back the way it was when I started. I did y by itself. So I'm going to subtract the 4 and divide everything by 2. And when I divide by 2, I divide the parentheses by 2, but not what's in the parentheses. So there is your, what we call the vertex form. From that form, you can see that your vertex is where? 4, comma, negative 2, meaning the axis of symmetry is x equals 4. Okay, everybody all right with that? Practice it to make sure. All right, then we got a parabola. The vertex is negative 1, 4. And I'm just going to stop right there. If I know the vertex is negative 1, 4, I'm thinking right here, I'm thinking this. I know my equation is y equals something times x plus 1 squared plus 4. Because that's how I get a vertex of negative 1, comma 4. Now the only thing I don't know is whatever that number is. In this problem it was a 1/2. I have no idea what it is. But I know that this thing contains the point 2, 7. So this equation must contain the point where y is 7 and x is 2. So 7 equals n times 9. Don't add the 9 and the 4. That would not be right. We want to subtract 4 and divide by 9. So n equals 1/3. So there's your equation. Some of you forgot that you needed a squared on there. That's what makes it a parabola. Got to have a squared in your equation.
Could you plug in the vertex for y and x and get the
What do you think? Did you try it?
I did not try to.
Okay. If you put in, you're going to end up with a 0 here, and that your n is going to disappear. So no, you can't. You have to plug in the point that's going to control the direction and width. This number controls direction and width. So that's the point that controls that. The vertex really doesn't have anything to do with it. And I'm not going to do number 3 because everybody in this room needs to be able to write the equation of the line through these 2 points. If you have an issue with that, you got to come talk to me about it individually, okay? And then the last one, we've reviewed this now a couple of times. I'll review it with you one more time. These power functions have 3 general shapes in quadrant 1. If we look at just the first quadrant, they have 3 general shapes. You have this shape, and this shape, right? And the shape is determined by the size of the exponent. So if we've got one shooting up like this, then we know the power has to be exponent, the power has to be greater than 1. So like x squared, x cubed, x to the 7/5. Anything bigger than 1 is going to have that general shape in quadrant 1. this shape, anything less than 1 by x to the 1/2, the square root of x, x to the 1/2, is going to have that shape. And then anything, well, I said y, I meant power, sorry. And then anything with a power that's negative will have that reciprocal function shape, right? So I said to you, which of those is the picture that could be the one that I graphed? And hopefully you said A. Because what would have to be true if B were the right answer? If B were the right answer, the shape would have to be this one, right? Okay. All right, so that's that. Put those away. Now, what was I doing the last time we were together? What was I doing? What did I stop with? Did anyone take notes? I know it's been forever. Chandler, the birthday boy, did.
We stopped on, it was...
You know what? Let's do this. Wait, Chandler, I'm going to interrupt you for a minute. Because it's your birthday, it's a special day. So I want everybody to take out a half sheet of paper. Quickly.
It's your birthday.
You got me.
Sure. All right, so you just need a half sheet of paper.
It's your birthday.
Okay. Okay, Chandler, come to the board. All right, now here's what's going to happen. Everybody write this problem down on your paper, except Chandler, who's up here at the board. Everybody's writing the problem down. Now, this is a little quiz, okay? Because today's Chandler's birthday. But we're going to do this a little differently. Chandler's going to do the writing, but you're going to raise your hand and offer Chandler suggestions. The deal is you only get to offer one suggestion. So if Leah gets him started on the problem, then she's done, and she has to sit there and hope that someone else smart will step up and do the next step, right? Okay? All right, so Chandler, feel free to get started on your own, and then when you get stumped, you'll turn around and someone will raise his hand and we'll call on him, and he will help you.
Was this what we learned when we were away? What did someone get?
I don't know. Someone just bought a ton of candy. It was probably for one of those projects. Because it's Twizzlers and Lifesavers and $14.50.
Wow. That's rich. Wait, do we finish sheet paper when we're done? Why are you asking stupid questions?
Chandler's not even asking questions. He's just kind of going on his own.
So, because it's negative, they both start down. But otherwise, you're doing it right.
Okay, so Thomas has said that he thinks Chandler had the right picture, but he had it upside down. Now, if you disagree with that, you're allowed to let Chandler make this new graph, and then if you want to change it like Thomas did, you're allowed. It's your grade. Everybody's going to get the same grade.
I suggest that you sit down now.
So, is there any more commentary?
I feel like we're missing something.
commentary, otherwise this is what we're going with. Oh, great, maybe. Yeah, the only thing more stupid is going out and Precal classes, doing it when the teacher's standing next to you.
I got a vibrate. So
Seriously?
No, I had a vibrate. So
Seriously?
No, I got a vibrate. It was a good call.
You got a call?
Yeah.
I hope it was a good call.
It wasn't. I
because
pushed the vibrate button.
it's
Yo, what happened to your ear?
Alright, so everybody gets a perfect paper and the 4-point bonus. Everybody that's here. Good job, Chandler.
Oh,
Happy
Marty.
birthday to you.
And
Now,
my grade is suffering.
This problem was, I mean, you had to remember some stuff. You had to remember that, okay, even power means up, unless it has a negative coefficient, and then it's down. You had to remember what happens when you have a squared factor. You had to remember where to put the zeros to start with, the x-intercepts to start with. So there's stuff you had to know to do that problem, okay? However, in the big scheme of sketching polynomials, this is as easy as it gets because the problem is already just set up for you. Most of the time they are not. So that requires a little more work. In order to sketch, we want it to look like that equation looks.
We did.
So the first thing we have to do is make that happen. So I'm gonna try this problem. We're gonna sketch this one. And I need everybody's attention because this is a biggie. This is an x to the 4th equation. So it's going to have a shape similar to the one Chandler just did. He had an x to the 4th equation. But in order for us to graph it, we're going to have to figure out where the intercepts are. We have to figure out where this thing is going to equal 0. And we don't have the factors. So we gotta get them. Okay, we gotta get them. Your first thought should always be, does this thing group? Well, first of all, there are an awful lot of terms up there. And I don't see any of them that seem to go together in any way that would give me like parentheses. Do you understand what I mean? I don't think grouping is in the works here. So what do we do if we can't group? We've got to get it factored. We're going to guess a number. Hopefully it will give us a 0, and then we can divide it out using synthetic division. Remember that from the other day? All right, so here we go. I'm going to guess a number. Now, I don't know about you, but this whole guess a number thing scares me a little bit, because how many numbers are there out there for me to guess? Infinitely many. This could be a long process. Would you agree? Yes. I can't tell you exactly which numbers would work. I wish I could. I wish there was a means to do that. But what we can do, not because of me, but because some really smart people a long time ago, we can narrow down our options. Instead of guessing from every possibility in the whole wide world, we'll create a bucket of numbers. Instead of having everything out there to pick from, we're going to have a bucket of numbers. And in the bucket of numbers are going to be the possibilities. The only possible numbers, rational numbers, that could work. The PRRs, as I refer to them, and some of you might remember that as P over Q or Q over P or something, you might have memorized it that way. The PRRs, possible rational roots, are factors of the constant. And by constant, we mean the term that has no variable. That's constant. It's -6, period. Factors of the constant over factors of the leading coefficient, which luckily for us is 1. It gets more complicated when there's another coefficient here, but one's easy. So, what are the factors of my constant? What are the factors of -6? Plus or minus? 2 and 3 and 6 and 1. I usually try to go in order, but since somebody said 2 and 3, I started. That doesn't matter. We just need them all in the list. And what are the factors of my leading coefficient? Just plus or minus 1. That's it. So, instead of having infinitely many numbers to start guessing, how many do we have? 8. Plus or minus 1, 2, 3, and 6. Don't guess any other numbers. So when I said we're going to guess numbers, or you said we're going to guess numbers, don't guess 5. Don't guess 4. Don't guess 8. Guess plus or minus 1, 2, 3, or 6. All right, so let's start guessing. I'm not ready to graph yet, so I'm going to erase that. So what would be a good number? 1? Let's try 1. 1 is so easy. You plug 1 in, you get 1 plus 1 plus 5 minus 1 minus 6. Isn't that 0? That is exactly what we wanted to have happen. So that's the number 1. The number 1 worked, which means one of our factors is x minus 1. Is that right? Now, who remembers, this problem's bigger than our last example, but who remembers what we do once we guess one that works? I synthetically divide. Now, you don't have to synthetically divide. I think it's quicker and easier to do that. Somehow you have to divide it out. So, 1 is the number that worked. My coefficients are 1, 1, 5, -1, -6. The one, that one right there comes straight down. Okay, so remember how this works? We'll go through it one more time. We multiply 1 times 1 and write the answer here. Then we add. Then we multiply 1 times 2 and write the answer here and add. 1 times 7, write it here, add. 1 times 6, write it here, and add. Did we want that to happen?
Yes.
Yes, because that is the remainder of the division. You're doing a division problem. If that isn't 0, then you have a problem, because you're supposed to be finding the factors. Factors mean divided evenly. Okay, so let's take a look at what's left. What's the left?
X to the 3rd.
Oh, whoa. X to the 3rd plus 2x squared plus 7x plus 6.
Okay.
Ay. We gotta do it all over again, folks.
Yeah.
Don't we? That doesn't group.
Why not?
How would it group?
Doesn't.
Okay, so now I'm gonna guess all over again. Do I have the same list of PRRs in this problem?
Yeah.
Yep, because that's still a 6 and that's still a 1. Could the number 1, which already worked, could the number 1 work again?
Yeah, it's a negative.
Yeah, it sure could. However, I'm not going to try it. Think for a minute. See how all these are added up? Your objective is to get 0, right? Is a positive number going to work for you? Think about that for a second. Don't you have to have a negative in there if you're going to end up with a 0 somehow? So maybe we'll try -1. It doesn't matter. Your job is to pick a number out of this pile and plug it in. So -1 would give me -1 plus 2. Oh, I can't believe it. -7 plus 6. We are the luckiest ducks. we got 0 again, first guess. What does that mean? That means another one of my factors is x plus 1.
Another one.
Because now negative 1 has worked, which means x plus 1 is the factor.
Yes.
Now what do I do? Now that I know negative 1 works, what do I do?
Divide simply.
I divide it out. So now negative 1 goes out here. Don't go back to the original problem. Go to the problem we have it reduced to. Anybody know what we call this guy right here? It's got kind of a funny name. It's called the depressed polynomial. So down comes the 1. And there's that 0 that I found, that I knew I found. Okay, now what? This is x squared plus x plus 6?
Yeah.
Oh my gosh,
6 degree and 2.
that is a factor. Doesn't, think about it now, think about it. What in the world am I gonna do? Because I'm supposed to be finding my x-intercepts so that I can graph this thing. So far, I have found 1 and negative 1, and now I don't know what to do. What should I do now? Well, it doesn't factor. If it did factor, I would factor it.
Quadratic Formula.
There's no negative in there, Chandler. Use 3 and 2, which would be a logical combination. It won't add up to 1 x in the middle. So what do I do? Quadratic formula. Sure, it's a quadratic equation. Don't I want to know what its roots are? So here we go. X equals negative b plus or minus the square root of b squared minus, oh my gosh. This is awful. It's imaginary. Now what does that mean in terms of my graph? It's not on the x-axis. These are called zeros, but they are not x-intercepts. Normally zeros and x-intercepts are the same thing. Not here, because these are imaginary. If you plug that, whatever that equals, if you plugged it in, you'd get 0, okay, but you can't graph it. All right, so help me out here. What in the world does this look like? Well, I'm going to tell you, you don't know for sure. I don't expect you to know for sure. Give me an option. What might be one thing it could look like? Knowing that it's a 4th degree polynomial, knowing that it has these 2 factors, these 2 x-intercepts that don't repeat, they're not squared or anything. Tell me something you know about this graph. Now be careful, what's its degree?
Oh, 4.
It's a 4th, and
So
what
it's
do we know
gonna
about
start
evens?
up and
It's
end
going to
up.
start up, so it's going to start up here, right? What's it going to do when it gets here? It's going to go through, it's going to come up here, what's it going to do when it gets here? It's going to go through. Now, do you remember Chandler's picture? What shape was Chandler's picture, if you had to describe it? It was an M or a W, depending on which way it went. This one's going to have that W shape. What I don't know is, where's the other part of the W? So would it be possible for the picture to look like this? Would that be a possibility?
Yeah.
Yes. But could the picture have looked like this? Would that be a possibility?
No. Yes.
Yeah, this is all I know is it goes through those 2 points, right? So I don't know, you don't know. In order to know exactly what it looks like, we'd have to do it on our calculator because we can't graph these 2 points. So lots of possible answers. You can even have a little dippy thing in here. It could go like that. So lots of possible answers, but what will the one thing, or the few things they'll have in common? They go through this point and this point, right? start up, end up, and somewhere in there, either over here, in between, or over here, there's another little piece of the W. We don't know where it is, unless we graph it on our calculator. Okay? Alright, that was kind of a toughie. Let's try another one. You all look like you're zoned out. I'd like to think you're super excited about this. This is a really cool skill you're developing here.
Is this board?
Yep.
Are we supposed to turn these hash beats in here?
No, I said everybody gets the same grade.
Oh.
So why would I want more paper? I don't. Alright, let's try one more. Let's have you sketch this one. See how far you can get with this one. And before you sketch it, make a list of your PRRs. Obviously, when I wrote the problem, it occurred to me grouping was not going to work. I hope that occurred to you when you saw a 6, a 7, and a 4. That, this isn't going to work in terms of grouping. So you're going to be guessing. What numbers are you guessing?
1, 2, and 4.
2 and 4. And because the leading coefficient's 1, basically that's it. Plus or minus 1, 2, and 4. Now, quick comment. If the leading coefficient had been 2, now it's not, I'll erase that in a minute. But if it had been 2, then on the bottom down here, you would have not just 1, but you would also have 2. And that means that you could have all these numbers over 1. So 1 over 1, 2 over 1, 4 over 1. But you could also have all these numbers over 2. So you'd have 1 half, 2 halves, and 4 halves. Now some of those are duplicates, and that's okay. But that would be a new one, right? 1 half would be an option. Now that didn't happen for us, so we don't have to worry about it. But it will happen in some of your problems. Okay, so instead of having infinitely many numbers, you have 6. You have 6. So the worst case scenario is you're going to make 6 guesses. All right, so start guessing. Tell me when you find one that works. And when I say works, I mean you plug it in and get 0. That's what you're trying to do. So let me know if you find one that works. What are you doing, buddy? Plugging in your head. Craig, you found one yet? I'm guessing, since nobody's found one yet, that 1 and 2 don't work.
I'll do -2.
You try -2?
1 and -2 don't work. Yeah, 1 and -1 and 2 don't work.
1 and -1 and 2 don't work. Okay, so we're narrowing it down. -2, 4, or -4.
That's not right.
What about 4?
I tried
4 would be 64.
4. Bring the attention to the problem, but we all know that one.
No. Okay.
Yeah, 4 works. There we go. We got it. 4 works. If you plug 4 in, unless I did wishful arithmetic, I think I'm right. 4 works. Okay? So what does that mean now? I'm going to divide it out. And again, if you do not get that 0 right there, something is awry. You've got to get that 0 because that means you found a factor. It divides it evenly. Okay, is everybody caught up with us? Everybody got 4 and you got it divided out? Okay, so what's left here? What's my depressed polynomial this time? X squared minus 2x minus 1? Deja vu. It doesn't factor. Now, do the quadratic formula though. This one's going to be a little bit different than the last one. What's different about this one? I still had to use the quadratic formula, but it's not imaginary, which means it's plottable. These did not come out with i's. I got the square root of 8, which is 2 root 2. So I cancel out my 2's here. And I came up with 1 plus or minus root 2. So in terms of graphing, where are my zeros? Well, the first one's at 4. I found that one by guessing. Where are my other zeros? What other points am I going to plot? 1 plus root 2, which is about 2.4. I'm approximating. And then 1 minus root 2, which is about negative 0.4. So that didn't factor. Our last 2 examples, the polynomials didn't factor, but we handle them differently. This one I can graph because its roots are all real. No imaginary numbers, they're all real. It's a cube. It's positive. What does that tell me about it? Starts down, ends up. There's a picture of that one.
So when we write like the polynomial form where it's x minus 4, would we write just x minus 0.4 and x plus, or x minus 2.4?
That is a great question, Chandler, and the answer is no. We would never do that. What we would do, you got a couple of options. What you would do is say x minus 4, and then x squared minus 2x minus 1. Because that does not factor down any further, so we just leave it as it is. So that's one option. If, and your homework does this sometimes, it says write as a product of linear factors. Now that means x minus, that means no squares. It means linear factors. Then you would go back to this and say x equals 1 plus root 2. Now, when the factor was 4, or excuse me, when the root was 4, the factor became x minus 4, right?
Yeah.
So if the root is 1 plus root 2, the factor is going to become x minus 1 minus root 2, because you got to move it all over here. You got to change the sign, move it all over. And then the other one was 1 minus root 2. So that would become x minus 1 plus root 2. And those are what we call the linear factors. Normally, this is good enough. But these would be, see how they're all x to the first? So those are linear factors. It's a great question from the birthday board. Okay, the reason I wanted to do those 2 problems so specifically is because I want you to understand they don't always factor all the way down. Sometimes you're going to have to use the quadratic formula. And when you use the quadratic formula, 2 different things can happen. You can end up with real roots, which are plottable. You just have to make them decimals and plot them. Or you can end up with imaginary roots, which means there's a bumpiness in the curve, but you have no way of knowing where it is, and that's okay. I mean, I get that. You just have to put it somewhere where it reasonably could be. if your job is to graph it. Okay? All right. Now, the next problem we want to do, we've done a lot of that. So the next thing I'd like to do is have you look in your book.
If we all agree on that one.
On page 209. 209. And I want to take care of just a few little odds and ends details that pop up in your homework. So on page 209, everybody's looking with me in your book on page 209. And we're looking at problem number 20. Now, graph the function in a viewing window that shows all of its extrema and x-intercepts. Describe the end behavior using limits. Okay, now, we have been spending a lot of time graphing these by hand. Now they're telling us to do it on our calculator. So let's go ahead and let's start, just so we have a starting point, let's start with a standard window. All right, so everybody's starting with a standard window, which is -10, 10 on the x's and the y's. You can always get that by going to zoom standard. That will set your window standard. Now let's type in our equation. And the equation I'm going to type in is the one that's written there. So number 20. Everybody knows how to raise to the third power, right, on your calculator? If not, please reach over and ask your neighbor. I want everybody typing this in so you're not confused when you sit down and do your homework. Now, we started with a standard window because that's what your teacher told you to do. We typed in the equation, we hit graph. Now, this is the picture that I got when I hit graph. I'm going to try to reproduce what I see on my screen. Here's my screen. Here are my axes. And this is what I've got. I've got this over here. And then I've got this and this. Does that look something like what you have for your picture?
Yeah.
All right, now read the directions again. What do the directions say? Make sure the window is the right size to show what? Extrema and x-intercepts. All right, now wait a minute. This is a cubic polynomial, right? Third degree. Am I seeing 3 x-intercepts?
Yeah.
I'm good. X-wise, I'm good. What do extrema mean?
The
Top of hills and bottoms of valleys. I don't see that, right? So my adjustment is going to have to be in my y's. So I'll go to my window, I'll leave my x's alone, and I'm going to change my y's. Now, I'm going to tell you the picture, I'll show you the picture I now have on my screen. Now it looks something like this, and I set it from 50 to -50. Do I need to make any more adjustments if I'm supposed to be seeing my extrema? I do. Do I need to adjust Y-min? No. Y-min's okay, I see that. Y-max has to be even bigger. So Y-max. Oh my gosh, I used 100 and it's still not big enough. Oh my gosh, I used 150 and it's not big enough. Finally, I can see everything I need to see if I use a window from -50 to 200. and negative 10 to 10.
So our answer is y within.
Yep. Now, there's one more piece to that, quickly. It says describe the end behavior using limits. The limit as x approaches infinity of your function, the limit as x approaches negative infinity of your function. Does this bring back flashbacks?
Yeah.
Yes, we've done this before. All right, so how does that work? Well, as x approaches infinity, what is happening to your curve? Going to infinity. As x approaches negative infinity, what is happening to your curve? Negative infinity. Now, one more comment before you leave. If your polynomial is cubic, listen to me, or fifth degree, if your polynomial is an odd degree, would you agree that one of these will be positive and one of them will be negative? But what if it's an even degree? Then they're both positive or they're both negative. We talked about that, right? Okay, I'll see you, I hope, tomorrow. What?
Would you like these?
No, I don't need those. Everybody gets the same grade. Perfect paper. Sweet. Plus double birthday bonus.
4 points.
Because who's your favorite teacher in the whole wide world?
You saved my grade.